Welcome to our webinar, Replatforming Without Blind Spots, ZOS LUW Monitoring for Data-Driven Migrations. My name is Radosław Runc. I'm CEO of Z-Race, and together with my friends, Markus from ITGain and Christian from MindBridge, we will provide you useful information how ITGain and Z-Race are combined. Integrated products can help you deal with the challenges in specific types of projects. The integration between Z-Race and ITGain allows for efficient monitoring across both ZOS and LUW environments for DB2, providing a unified view of performance data. This capability is especially valuable for organizations undergoing mainframe application modernization, as it ensures consistent insights and control across hybrid infrastructures. Christian, kindly please present our agenda for today and continue with your content.
Perfect, thank you very much. Good morning, everyone, and I'm glad to be here to discuss this topic. That is quite a very hot and very important topic in our industry today. So this is the agenda. So we have first an introduction, replatforming and rehosting from the DB2 ZOS to DB2 LUW, a very popular choice nowadays to go from DB2 to DB2. Then we will discuss the drivers behind DB2 ZOS to LUW migration. Why do we talk about migrating? What is the motivation behind all this? We will discover that there are some gaps that we need to fill in. The mainframe platform is not the same as the distributed platform. And in that context, the workload identification with set client info is a quite popular choice. We will discuss very briefly how that works. Then we will move to Z-Race, deep observability for DB2 and ZOS. Then DB2 LUW observability with ITGain for database. And we have a live demo. That's it's going to be quite revealing, I think. And then we have at the end question and answer, open the discussion and wrap up. Right, this is the agenda for today. A lot of interesting content, and then we go directly to the topic. Why replatforming? As I said, it's a very popular topic today in our industry, and many of the most important IT organizations are running on the ZOS platform, right? So the biggest insurance companies at the bank are typically running on ZOS for many good reasons. Nevertheless, in my experience, in my area, and I dare to say that it's a common topic in the IT industry in general, replatforming ZOS has been a very hot topic. It's not a new topic, it's something that is going on for decades. So some companies that we are collaborating with are evaluating permanently how to move away from ZOS on a regular basis for the last 20 to 30 years, for example. In my opinion, most organizations running on ZOS at least considered or evaluated replatforming from ZOS. And there are several questions or several reasons behind it. There is not always the same motivation behind a project as such. For example, cost evidently is a big motivator. So there is a perception or there is a motivation to move the IT infrastructure to a cheaper solution. So cost is a very important point. But also there are considerations regarding a vendor lock-in, in the sense that many organizations find themselves in a situation where they are depending on a few vendors for the software. And so we can see in the industry that the vendors are consolidating, if you like, so that gives some of them a prominent situation or position where they can increase cost, for example, and there is kind of a lock in there. The modernization is also a very topic. Is a very hot topic. Is how can we modernize the IT infrastructure in terms of making it more agile or making it faster to market? And there are some considerations regarding people's skills as well. So this is not a new topic. It is a hot topic, and in general terms, in my opinion, even the organizations that are committing fully to the mainframe as their IT infrastructure are at least re-questioning the issue from time to time. So in this context, many organizations have succeeded on replatforming, and I'm talking about replatforming and not migrating, and we will see why. And many have not, right? So there are plenty of examples in our industry where the migration of replatforming or modernization of the mainframe is a sad story. So that happens. The replatforming is a very complex process. And very often, there are delays and there are budget problems. So that is something that we need to keep in mind. And this presentation is going to focus on why replatforming is difficult, not impossible, but it's not a light project. There are many important considerations to keep in mind. Can we please move to the next one? So a little bit expanding on the motivations, we discuss cost, we discuss flexibility, we discuss a reduction of vendor lock-in, and we discuss the skill consideration. So there is no single motivation, and often it is a merge. It is a mix of different problems. For example, the lack of skills. So we are confronting the problem of the generations that are leaving the mainframe because they are going into retiring, for example. And this situation of a potential lack of skills is often, let's say, compounded with companies that have, in a way or another, decided that they will leave the mainframe and therefore have not invested on skills on the mainframe infrastructure. That creates this kind of issues, and combined with, for example, cost, it can motivate companies to find a solution. So often companies find a mainframe that is very expensive, and they are finding that the resources are lacking. And then the question is, what do we do next? If we move to the next slide, please. There are several strategies to cope with the problem. There is no single solution, and the replatforming of the mainframe infrastructure should be put into context. So there are many examples, but as there are no two big IT infrastructure or IT application environments that are the same, there is no single solution to the problem. There are many strategies. One is the modernization, the other one is lift and shift, and the other one is replatforming, for example. What is the difference? Modernization is the approach that companies are taking when they decide that they will stay on the mainframe, but they will do it more modern. For example, we have hybrid situations where we are mixing the mainframe with cloud integrations, for example, and we try to do DevOps on the mainframe. It is possible. Or we try to use more modern coding languages on the mainframe as well. It all depends on what is the problem that we are trying to solve. If we keep in mind the major motivation that we discuss, the cost, the flexibility, the reduction of vendor lock-in, on the lack of skills, depending on what is the problem that we are trying to solve, we will need to apply the strategy that is best for that. Another very common approach is the lift and shift, and it's kind of a copy and paste approach, or to some extent, we can simplify this approach by saying we are moving the problem to another platform. And that is essentially we take what we have, We take the approach, the way of working, like we continue to use COBOL and PL1 code. We continue to use JCL, for example, and we go to a distributed platform around, for example, Micro Focus Enterprise Server, Linux and DB2 on premises or on the cloud, for example. And what we are doing is capitalizing on what we have and try to modernize the infrastructure. This is an approach that is working also very well. It has the problem to give you the perception that is easy because you're just doing a copy and paste. Nevertheless, as we are going to see later on, Linux is not the same as COS. DB2 LUW is not the same as DB2 for COS. So therefore, there are gaps that needs to be solved. The other approach or the other strategy is replatforming, and that is changing the platform. And let's say we convert what we have on the mainframe in a way or another to a new modern infrastructure. For example, DB2 data sharing could be converted to DB2 pure scale, and we can move the application to Linux, right? So this is also a common approach. Again, there is no magic solution, and in my opinion, we need to start by identifying what is the problem that we are trying to solve first. Second, what do we have in-house that we can recycle, or in other words, capitalize to make the exercise easier, and then to design a strategy and see how that's evolved. Right? So can we please move to the next slide? This is just a little example of what we could call an hybrid mainframe modernization when we have a partial modernization strategy. This could be the end target, or this could be step-by-step approach. So we have seen in the market companies that create a vision or roadmap where the end strategy is to be completely out of the mainframe, but in order to facilitate the migration, if you like, we start by migrating the applications, for example, and we keep a mainframe as on DB2 as a DB2 server. So somehow the mainframe becomes a back-end server where you have DB2 for COS and you have the batch processing, for example, and the applications are between quotes modernized to a distributed environment like .NET on Windows or applications running on the Westfield application server. And slowly and sometimes with an application-centric approach, we migrate the rest of the infrastructure where we get finally on the target architecture where we have, for example, all DB2 LUW. So it means that given this very complex, somehow longer-term project, we will have situations where we will have a mix of platform that we need to handle. Right, if we could please move to the next slide, please. And there is the situation where we need to start to dig into the platform differences that need to be compensated. So the DB2 is quite nice as a target because from a COS point of view, the DB2 LUW as a target, for example, DB2 on Linux or DB2 pure scale, is a very, very good landing platform as, for example, I would say most, if not all of the SQL is compatible. And we can recycle many of the approaches and procedures that we have. Nevertheless, there are differences that need to be compensated. So DB2 for COS and LUW are very similar, but they are not exactly the same. So volume testing is capital. It means unit testing that is successful is not necessarily a guarantee that you will not get issues when we are testing volume. And in order to volume test the applications, you need to create the workload and you need to measure it. And we will go into more details later on. I really like to say when we are discussing about this point is that if you cannot measure it, it doesn't exist. It's a very simplified vision of the situation, but monitoring and alerting is very important in the context that we are discussing today. We can capitalize on external store procedures. There is a big overlap between the platform there that is very interesting. We have some issues with resource management. The mainframe is really great on setting priorities and assigning resources depending on the service classes, for example. There is something like that on the DB2 LUW, but it's not a drag and drop solution. Can be done, but it will need some attention as well. All right, can we please move to the next one? Monitoring and alerting, that is a little bit the core of what we're discussing today. It is a quite important topic that needs, in my opinion, to be evaluated in the beginning of the project. So monitoring and alerting is very important. Typically, the mainframe platform are very mature on monitoring and alerting, and we need to rebuild the same solution or the same level of service in the target platform. For example, performance monitoring, obviously. So for example, do we get the same level of service? Are the batches, transactions running as fast as desired? And if not, why? Capacity planning is very important as well. Typically, the mainframe is very mature on this and also on chargeback. And what we have found in this kind of project is that the mainframe users, they tend to want to find the same level of solutions in the target platform. So performance monitoring, capacity planning, and chargeback, meaning how do we map the total cost of the infrastructure to applications is a common concern for users migrating. So there are several solutions in the market. The one-to-one mapping is difficult to find, but it is possible. For those that are using DB2 for COS data sharing, there is the pure scale solution that is the equivalent where there is an extra level of complexity, but as we are going to see later on, there are solutions in the market that also include the pure scale monitoring. DB2 packages is a rare concept in DB2 for LUW, but as we are going to see today, it is integrated on monitoring solutions, but the package-oriented monitoring is the by de facto approach in DB2 for the US. We have more flexibility in DB2 LUW. So not all is bad in somehow. There are very nice surprises when we move to the DB2 LUW platform that make the life of the application environment even easier. So there are very nice opportunities to be exploited. But we need to think about developing an integrated monitoring solution for DB2 and Linux, right? If we please move to the next slide. As I said, the tools and utilities on COS are very stable and mature and very old and very proved. In general, DB2, LUW, and Linux tools are less mature in the sense that are more modern. It doesn't mean that they are not stable, but they do not have all the 40 or 50 years of legacy history behind, right? The granularity is less just because the platform calls for that. So there is a conversion to be done there. When we look at how do we handle the monitoring on the mainframe, how do we handle the monitoring on DB2 LUW? For example, there is no real need to count necessarily the I/O operations on the distributed platform, because the distributed platform is more mature in that sense than the COS in terms of performance. The DB2 instrumentation or traces is different. So we need to look at new eyes, what we get into the DB2LW platform, but I'm confident that you will find the information that you want. There is no SMF equivalent. We need to work on that, but when we look at the performance of a query, we tend to like to have a holistic view where we include the let's say the infrastructure, the ZOS view as well. So that, for example, can be done and has been done, as we are going to see later on, by integrating, for example, the SAR information. All right, can we move please to the next one? In the context of what we are discussing, the WLM client information is a great opportunity to identify the workload at transaction level, at job level, and even at query level. This is a strategy that is available on DB2 for the US and on DB2 for LUW as well. And to some extent, you can start planning for the next migration already when you are on DB2 for the US. So the WLM client information allows us to identify or to populate fields that are going to be transmitted during the end-to-end application and database dialogue. And that will allow us to look at workload, to classified workload, to create reports. Is a very useful tool that is available on COS that can be recycled very well on DB2LW. So in this slide, you see some details about the ZOS implementation. And if we move, please, to the next slide, we can see here how we can exploit this information when you move to DB2LW. So we have seen cases where we can even move the database and keep the applications as they are, and we can still take advantage of this kind of information. So we see here an application snapshot picture that is coming from the DB2LW activity, when we can see the client user ID, workstation name, application name, and accounting string that are user provided information that can be followed all the way from the application to the database. Can we move, please, to the next one? What is the goal? The goal is that we are able to exploit, for example, the WLM client information in order to identify and to classify the workload. So what we see here is two screenshots of an SMF RMF report where we can see at the top the CPU utilization, and we can see at the bottom who is the marginal contributor to the CPU utilization. And this is what we would like to see in the DB2LW platform as well, when we exploit, for example, the WLM client information. It doesn't need to be a black box. It is not a black box when you capitalize on the tools and the monitoring approaches that we have available when we move from a DB2 for COS to a DB2LW platform. All right, so on that, we can move to the next slide, and we can move to the next presenter.
Thank you very much, Christian. So here you see just a few information about the Christian company, the MindBridge, our partner in today webinar. So in my content, I would like to present our holistic observability approach that covers both open systems and mainframe IT infrastructure, two worlds that typically operate in silos. At the heart of the mainframe monitoring capabilities is Z-Race, a purpose-built observability platform designed specifically for ZOS environments. It provides deep visibility into workload behavior, transaction flows, and system performance, offering tailored analytics for mainframe infrastructure. What makes Z-Rays truly powerful is its ability to integrate seamlessly with leading observability tools across the enterprise. We integrate with Dynatrace to deliver unified AI-driven insights across distributed and mainframe systems. We connect with Elastic, enabling rich log correlation and search for cross-platform troubleshooting. And we also provide native integration with ITGain, the product of our today business partner for databases, allowing detailed DB2 performance analytics, proactive tuning, and deep query diagnostic to be surfaced within the Z-Rays context. By bringing the tools together, Z-Rays creates a unified observability layer that connects legacy and modern environments in a single actionable view. Let's take a closer look at how Z-Rays fits into a modern umbrella monitoring strategy. On the left side of the circle, we have the mainframe domain, where Z-Rays operates as a dedicated observability engine. It collects performance data from ZOS systems, including address, spaces, kicks, regions, DB2 subsystems, and batch processes. This gives us deep insight into the health and behavior of mission-critical workloads. On the right, we see non-mainframe platforms, cloud, Windows, Linux, Kubernetes. Here, we rely on Dynatrace and Elastic, industry-proven tools for application performance and log analytics. In the center, Z-Rays acts as an integration hub, bridging the gap between these two environments. It doesn't replace existing tools. Instead, it complements them by integrating mainframe telemetry with Dynatrace, Elastic, and also with ITGain for databases, which brings powerful DB2 performance analytics to the table. So what is the value of this? You can keep your existing ecosystem while gaining end-to-end visibility from cloud-native microservices to batch jobs running on ZOS all in one place. This is how we create a single pane of glass for your IT operations. Now let's take a closer look at how Z-Rays provides deep infrastructure observability for mainframe environments. The Z-Rays platform is built on a set of modular agents, each dedicated to a different area of the ZOS ecosystem. In the center, we see the Z-Rays engine surrounded by its specialized collectors, SMF, RMF, log, SQL, OSA, SDSF, and DB2 IFI agents. Starting with SMF agent, this is the heart of performance monitoring. It gathers critical metrics directly from the system management facility, covering CPU, Z, IIP, and ICF utilization, memory usage, channel paths, FICON, disk systems, and even security events or SAP workload metrics. It also collects DB2 statistics and accounting data, TCP/IP, stack performance, and application subsystem metrics like kicks, MQ, and WAS statistics. Next, we have the DB2 IFI agent focusing on threat activity and SQL execution, including dynamic versus static SQL usage. And finally, the SQL agent, which enables live SQL execution and data movement. For example, sending queue replication metrics or table spaces stats directly to Dynatrace. What this means is Z-Rays doesn't just monitor the mainframe. It provides granular real-time insight across only core subsystems, enabling integrated observability with your enterprise stack. This slide illustrates how Z-Race provides deep step-by-step observability for DB2 on ZOS, helping operations teams troubleshoot and optimize performance issues with precision. So we start with step 1. Check application or DB2 errors. This helps us identify which subsystem or application is causing the issue. We begin with logs, DB2 logs, system logs, and application logs. Next is step 2. Verify address space utilization using RMF and SMF data. Here, we look at the key workloads like DDF for distributed access, KIX regions, WAS, JVMS, or any other subsystem that may be consuming excess CPU. In step 3, we dig into accounting records to find where time is spent, CPU or wait time, and check DB2 subsystem statistics to uncover broader performance bottlenecks. And finally, step 4. Using DB2 IFI data, we go to the statement and thread level. Z-Race helps identify problematic SQL statements and slow-running threads, all visualized in real time via integrated dashboards or even streamed into Dynatrace or ITGain. This structured approach ensures that we move from symptoms to root cause efficiently without guesswork across every layer or DB2 stack. So at this stage, I will hand over to Markus. Markus, in your hand.
Thank you, Radek. And just a few seconds to prepare my slides. So thank you for showing us how Z-Race can work, and I will go on and show how our solution, speaking for databases, might be a good solution for getting even more detailed DB2 information. So as Christian said before, there are not that many tools on the market that have a long history in monitoring, and the ITGain journey so far began 2003. And that was when we had the first ideas about how to monitor DB2 LUW. So we had some consultants and projects where they migrated DB2 from the ZOS platform over to LUW, and there had been the big lack of monitoring infrastructure on the LUW side. So they came up with some scripts, some tooling, and in the end, they built a product that got released 2004, and that developed and was enhanced over the years, like 2010 with the new front end switching from Java to .NET and C#. 2017, we integrated the ITGain for DB2 version 5.0 with even more historic aggregation information for the DB2 LUW side. And within 2021, we released ITGain for DB2 version 5.4, which is more or less the last version we released for the old infrastructure, and switched over to ITGain for databases and integrated even more databases than DB2. We started with DB2, but we brought in Oracle, MariaDB, MySQL, SQL Server, Azure, PostgreSQL, and added even more features for the market, like pure scale information, DPF, HADR, and all the new stuff that had came up with the monitoring infrastructure on the LUW side. So there's more than 20 years of experience in monitoring, more than 20 years in experience of developing a monitoring infrastructure and monitoring tool, and now an observability tool for your DB2 databases. So from the customer side, we are asking our customers from time to time how they are doing with ITGain. And one customer said that the most impressive thing is that ITGain integrates with Grafana as of now. So the new ITGain for databases has its integration with Grafana. And this makes it easy to create target specific dashboards, like for management, for developers, for special testing scenarios as well. So what we do is we build the dashboards based on the customer feedback and customer requirements. And the first customers had been our own consultants. And as of now, we have more than 40 customers worldwide. We feed our managed database service team with our monitoring solution as well. And we're currently in talks to integrate it in even more tools like with D-Race as well. So SpeedGain is not the, let's say, all-in-one solution for all your databases and all your system metrics and all what's going on in your environment. It's more or less one part of your complete observability stack. So we integrate with Prometheus as well, with Logstash, with Elasticsearch, with Loki, with other tools. And we are the part to get even more details on your databases. So most of the customers are having some kind of infrastructure for monitor their environment and have high-level monitoring information, like is your database available? Are there connections? When did the process start up? Is the cluster available? And so far and so forth. But they do not have information about which SQLs have been running low or slow, or are there any locking contentions in terms of log weights or in terms of ledgers. And that's where we kick in and we do the integration stuff to have the complete view of all your complete environment of all databases, all monitoring information in the same place. The architecture behind it, and it's, let's say, a bit more technical on this side. We have the open modern world that we have in hand. So we use containers. You can deploy it on premise and on cloud as well. So we have our collectors that are remotely connecting to the databases. So there's no need for an agent or any application that is running on your database servers. So we are collecting remotely and connecting to the DB2 database and get the information from the monitoring infrastructure. So no need for snapshots that are collected. It is more or less like select star from monget database, monget table functions from the DB2. Same goes for PostgreSQL and all the other databases we can connect to. And we have an, let's say, open repository, which is based on PostgreSQL with an extension for time series data so that you can deep dive into the data with your own SQLs if you want to and build your own dashboards and alerts as well. On the front end side, we do have REST API services so that you can integrate in CI/CD pipelines quite easy and configure your open side. We have Grafana in place for all the dashboarding stuff and the web front end for an easy configuration interface, like which databases to connect to, which users to use, which interfaces to pull in which frequency. At the front end side as well, there's an Nginx reverse proxy inside our installation, which routes all the requests from the web client as well. So the front end completely is based on browser technology. What we do have is a central observability solution for different databases. So no need to have more observability tools in place for just monitor your different RDBMSs. As said, it's completely agentless. So you do not need to install anything on your DB2 or LUW or on your Oracle SQL Server as well. We do have the option to create custom dashboards. So it's quite easy to integrate in your observability stack. So for instance, if you're running your own Grafana on-premise enterprise solution or Grafana cloud solution, you can bring in SpeedGain as a data source and bring in our dashboards or your custom dashboards just to connect to the repository. The complete configuration is policy-based. So you can just imagine like have a base policy for getting the data every 5 minutes from the DB2 database. And if you're running a problem scenario, you maybe switch to a problem policy that collects the data even more often. Your installation effort is quite less and maintenance as well. So it's cloud native based. We have Helm charts, we have files to integrate in Podman and Docker Compose and Kubernetes and OpenShift, all the stuff, and Cloud Pak for data as well. And we have a real good repository that is even performant over the years. So we have customers having data with for more than 2 years of history to look back how has your job been doing 2 years ago. Christian has said something to how timing and metrics are collected within the different parts of a DB2. And DB2 LUW is a bit different from the US side, he said, and I can confirm that. And the basic parts to understand how monitoring, performance monitoring is working on LUW is that you have to understand the request time distribution. So basically, DB2 LUW is measuring the total request time and dividing it up in total wait time and the total wait time, again, a lot of other different wait times. And I've just copy pasted from the IBM documentation, and it's 11.5, 12.1 is more or less the same. And those marked in yellow are all wait times, and those are that you don't want to see that much in your DB2 because DB2 is waiting on something in the back end, like direct read timings, TCP/IP receive and send, caching facilities, space mapping if you're running on pure scale. But what you want to see is this more lighter green area, which is actually processing time. So where DB2 is actually currently working on your SQL stuff. And the best part would be to have your total section processing time, which is the real SQL running in your engine. And all the rest is just getting the data to run that SQL. So this is measured at database level, at connection level, at SQL level, at activity level. So we'll always find these request time and wait time distribution within ITGain as well. And that will be the key to get to the root cause of your performance problem. How that can look, just a few screenshots that you can view afterwards, because we will get into the demo in quite a few moments. What you get from the ITGain, and what's the ITGain experience? We do ship more than 150 dashboards within the current version, which is version 2.0. We have 56 dashboards, especially for the DB2 LUW area, and we are collecting more than 3,500 different metrics per every single DB2 LUW database that you put into monitoring. And you can configure which metric and which interval. And this is all served in the minimum infrastructure with 4 cores and 16 gigs of RAM. And in the main part, 100 gigs of storage are far enough to have performance data for one database for at least a year, because we do have a compression rate roughly of 96–95%. Said with the integration of D-Race, this just another tool getting performance data, and that D-Race is writing their data into our own repository. And what we can do is to integrate this data with specialized dashboards to get the data from the D-Race infrastructure as well. So what I will show within the next demo will be how can we look for different dashboards, which metrics are shown. And as of now, we do have 21 Z-Race dashboards in ITGain to show different areas of the DB2 on the US side, and one specialized to have a direct comparison. And that's where I go to the live demo. And let me just switch out PowerPoint slides and move over to my web browser. So if you open up ITGain for databases, it will show you something like this, more or less like menu infrastructure and the first big dashboard, so that you can get an idea of which tables are currently used the most within our internal repository, the alerts that are currently on fire, and the database that you currently are going to monitor, like Azure SQL, DB2, some generic information, Linux, MyRIDB, MySQL, Mongo, and D-Race as well. At least some more information what's new within with the ITGain installation, how many nodes and databases are currently in the system. And what we have all over the place is, let's say, a drill down facility. So every single text box that is blue, the typical hyperlink blue in the browser, can be clicked so that you can deep dive into specific area. Like when we click on Z-Race, we will go for the first D-Race dashboard as well. So for instance, it's the D-Race DB2 overview dashboard, giving you the information about CPU usage by job and the zip usage by job, some performance information about SQL stats, like closing cursors describe fetching and open cursor information per second, some free memory on the L part, max space information, and you can deep dive into even more dashboards, like going to ledge information, and you can just easily scroll down and even see more specific metrics on the ZOS side, and even can switch to different other dashboards like SQL stats or even like dynamic SQL statements. The best part is that we do have historic information. So DRace is collecting the records from the DOS side, is parsing them and sending it over to our repository. And you can quite easily switch from last 3 hours to, let's say, last 6 hours. Can switch to a specific point in time by just click and select a specific box to, let's say, select the specific time frame to look for a specific performance issue, and even can switch back to one relative time to switch to metric from that place. So going back to just, let's say, look for what DB2 LUW can show us within SpeedGain. So clicking on DB2 will bring you the information which databases are currently within Monitor, to give you an idea about your current environment on your distributed side, which can be even more than just, let's say, the DOS big mainframe infrastructure. So we have more tiny ones on displays. As Christian said, mostly customers are trying to run on PureScale if they are migrating away from ZOS. So PureScale might be an opportunity to look for. And we have different or specialized dashboards for PureScale as well. So for instance, clicking on PureScale, you will deep dive into the PureScale information. So how is my cluster doing? How is CPU utilization? How is my system load? And the first time, how is my request time doing? And if I want to look for the request time distribution, there's a member time distribution dashboard that's specialized for this, showing you for each member running in your PureScale cluster, how the request time is divided into the different parts, like compiling, section, waiting, rollback, or whatever. And you can deep dive into that as well. If you're running, let's say, the mentioned testing parts when you're migrating to DB2 LUW, you're mostly looking for what is currently going on my system, which is more or less like a live view. So we integrated a specialized dashboard looking for the main KPIs of a DB2 LUW, like the system metrics for CPU usage and the load of the system. And once again, request time distribution. So where is DB2 spending most time for? Which wait times are utilized the most? And even more informations like how many applications are currently connected, how many agents are used, connect requests, authentication requests, and all the stuff needed to look for even more details on your DB2 LUW. And additionally, what's currently going on in my system? So which activities are currently running? And how long are they running? And within this example, as we are on a test system, it's just the monitoring itself that's running, so no performance testing as of now. As said, you have the request time distribution on different levels. So for instance, the starting point is the workload area. So you can look for different request time and wait time distribution. And as Grafana, typically you have a lot of filters and buttons in the upper part, like switching to a different database. Let's say let's go for this one. Will directly change. So for instance, you can, as said, just deep dive, click on the series, and you can just easily switch to the top 25 SQL statements that have been accounting for the CPU time usage. And I've put in some special statements for today, like select I love performance as qualifier, blah, blah, blah stuff. And one click deeper, you can even deep dive information of this specific SQL, so you can see how it's been doing over the last, let's say, minutes, hours, or even days if it's running for longer. This is quite good to have an afterwards look or direct look during the migration. But as said, we have a more integration kind of stuff in view. So we integrated let's say, to look for the specific dashboard. We have a dashboard that is especially used for when we have ZRace and SpeedGain together in place, so that you can look side to side from your ZOS system to the LUW system. Imagine like running a typical workload on DOS and the same workload on a LUW copy. And you can directly see how many statements have been executing, CPU time, get pages, and on DB2 LUW side, the pull data logical reads, for instance, and the same information on DB2 SQL engines, like the ZOS side on the left hand and the LUW side on the right hand, and can directly see which statements are utilizing most of my time, most of the CPU, and are they doing worse or even better compared to before. As Christian said, DB2 LUW is working some kind of different when it's coming to SQL execution and packages. So we do not have at first place the information about which jobs have been running, and you have to use the WLM set client procedure to give DB2 LUW the information which jobs are currently executing this stuff. And we have added for our, let's say, migration customers, some specialized information within the backend. So we have some aggregates going on the background and aggregating data based on this special registers in your DB2, and are grouping them up together to give you a job feeling and a job view within ITGain for databases on the DB2 LUW side. And what you're currently seeing is the job analysis dashboard, which is specialized for the jobs based on the client application name. So you can put in any metrics, and I put in job 1, job 2, and webin for the webinar, and it will group up the information and automatically aggregate this information based on the connection information. So this is some kind of looking more detailed into the area where is your ZOS job running compared on the LUW side running well as well again. So this is one of the big opportunities we have, because we are on the, let's say, observability stack and not on the monitoring stack. If you would monitor, that would be hard to get these metrics, but on observability, we have the data. We just need to integrate, let's say, even more dashboards to get the more insights on specific area. And I think this is where my live demo is currently ending, and we have a lot of time left for coming up to questions and concerns and even more details if wanted. So are there questions for now? And I'm looking for the Q&A section. Drum roll. And if no one is asking, I will, let's say, talk about some projects we have done with this tooling. So there's a big insurance company in Germany that switched for, I think, 5 years ago from DOS to LUW side. The first time user of ITGain for databases. So they had been in the piloting phase and beta phase and had integrated most, we have integrated most of their requests into the product and had some specialized dashboards for them as well. So that they have, as of now, 10 to 15 dashboards for the management to see whether a DB2 LUW is doing great, because before the management had some specialized dashboard on the ZOS side. And I can see something in the chat from Fred. So if you want to monitor both DB2Z and MS SQL and Azure Cloud with license, which you need. So for DB2Z, you would need some special license from DRace, and for SQL on Azure Cloud, some specialized license from ITGain, but we can bring in, let's say, a centralized contract and a centralized budget, so that you don't have to sign both, but you can sign by one, and then there would be a license to feed it up. And you will have to integrate ZRace, let's say, different from ITGain, because ITGain is just the user of DRace data. And it's integrating all the dashboards, and on customer request, we do integrate even, let's say, the job view, because the job view is more or less based on where and how do you specify your job name in those special registers. So not every customer is, let's say, setting the first 5 characters. Some are using the last 5 in the client accounting string, and some are using the client application name. So that's always customer based and not directly within the product, but will be customized for the customer and then send it over. And there's no need to, let's say, do a reinstall or migration. It's just another SQL running on your backend and integrating a dashboard into your Grafana installation. You're welcome, Fredrik. So any other questions so far or at this place? Well, then thank you all for attending this session today. As mentioned, we are recording this session and we'll send it over to you afterwards so that you can review this session. And if you want to, feel free to ask one of our speakers of today if you have any questions regarding the products or the projects or any references, or if you want to have, let's say, trial, demo, POC, or whatever. Thank you very much. I think Radek wanted to say something additionally.
Yeah, so just for concluding words, so we covered today two integrated products. So it was SpeedGain from ITGain and Z-Race from Z-Race, from the company of the same name I represent. And also we talked about our expertise in this challenging replatforming projects. When the expertise of MindBridge, our next partner of this webinar, plus of course ours, ITGain and Z-Race, can bring a lot of value to you. So if you may have maybe some specific, you want to just to dig down and ask us to present some recommendation information about some specific topics covered during the webinar, or maybe something new, we would like ask you to refer to us with this. So maybe it will be the idea for the next webinar, or maybe it will be the good opportunity to connect and dialogue one-to-one. Yeah, this is, by the way, I would like to finally thank you very much, Markus and Christian, for the perfect performing of our webinar. Thank you.
Thank you too, and thank you very much for joining. Bye-bye.
Bye.
Bye-bye.